Welcome to MetaMinds Academy. This is lecture series on Fourier series concept. In this lecture series, we are going to learn the concept of Fourier series and we are going to solve n number of problems based on Fourier series. This is a very important topic in the examination point of view for BTech students particularly, and you can easily get pass mark if you have good command over this subject, this particular topic, right? So let us go into the topic. In many engineering problems, especially in the study of periodic phenomena, it is necessary to express a function in a series of sines and cosines. So we are going to express given function in terms of sines and cosines, right, as a series of sines and cosines. So particularly single valued functions like in applied mathematics can be expressed in the form a naught by 2 plus n equal to 1 to infinity summation an cos nx plus summation n equal to 1 to infinity bn sin nx. So this is called the Fourier series expansion of the function f of x. Okay. Now we have to remember some formulas in Fourier series. The formulas are, the first formula is Euler's formula. So here this is the Fourier series expansion of f of x, a naught by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. Here we need to find out the values of a naught, an and bn. That is what we are going to do throughout the Fourier series concept, right? So while finding the series, we have to find out a naught, an, bn. So what is a naught? A naught is 1 by pi integral alpha to alpha plus 2 pi f of x dx. An is 1 by pi integral alpha to alpha plus 2 pi f of x cos nx dx. Bn is 1 by pi integral alpha to alpha plus 2 pi f of x into sin nx dx. Here n is running from 1 to infinity. So these values a naught, an, bn are called the Euler's formula. They are called Euler's formulas of a naught, bn, an and bn. So what is this interval here? Interval is alpha to alpha plus 2 pi. So what is the length of the interval? If you have an interval like a comma b, the length of the interval is b minus a. So here b is alpha plus 2 pi and a is alpha. So length of the interval is 2 pi. So whatever the value of alpha, irrespective of the value of alpha, the length of the interval is always 2 pi. So whenever the length of the interval is 2 pi, we will have pi over here, right? That is why half of the length, it is 1 by L, 1 by L, 1 by L. So we will see a concept of arbitrary interval in coming lectures, right? First we are going to deal with intervals of length 2 pi, and you have to remember some these kind of formulas. It is integral alpha to alpha plus 2 pi cos nx dx and alpha to alpha plus 2 pi sin nx dx. Both are 0 provided n is not equal to 0. Remember. So if n is equal to 0, this is cos 0 is 1. In that case, this interval value become 2 pi. If n is 0, sin 0 is 0. In that case also, this integral value becomes 0. Right? If n is 0, this only differs. Next, integral alpha to alpha plus 2 pi sin square nx and cos square nx, whatever we have sin square or cos square, the value of the interval, value of the integral is pi, right? Whenever n is not equal to 0. Next, coming to this formula, integral alpha to alpha plus 2 pi sin mx cos nx dx. Sin mx cos nx. See, coming to this formula, third one, integral alpha to alpha plus 2 pi sin mx sin nx. See here you have sin mx sin nx, cos mx cos nx, and sin mx cos nx. You have three different combinations of sin and cos, but the concept is here the important point is m is not equal to n. M is not equal to n. In that case, the value of the integral becomes 0. If m is equal to n, what happens if m is equal to n? If m is equal to n, this becomes sin square nx. That means this value is pi. If m equal to n in this becomes cos square nx. The value becomes pi, right? So you have to remember these two important formula. These are very frequently used in Fourier series. Sin n pi is always 0. Whatever the value of n, right? The value of n means n is an integer. So whichever integer you take in place of n, sin n pi is always 0. And similarly, cos n pi is always minus 1 power n. Cos n pi is minus 1 power n. So sin n pi is 0 means sin 0 pi, 1 pi, 2 pi, 3 pi, whatever. Sin 3 pi, sin, whether it is even or odd, sin minus pi, sin minus 2 pi, all are 0. Whereas cos 5x or cos 5 pi is minus 1 power 5. It is minus 1. Cos 4 pi, if you take cos 4 pi, it is minus 1 power 4, which is 1. So whenever n is even, this becomes 1. Whenever n is odd, this becomes minus 1. And you remember these two formulas, we use these two formulas frequently in Fourier series expansion. Integral e power ax sin bx dx, integral e power ax cos bx dx. So you can remember these two formulas. See, this one is common for both the formulas. E power ax by a square plus b square is common, and we have two terms. In the first term we have a, second term we have b. A, b, they are also common. Whenever you have sin here, you will get sin first and then its counterpart cos. Whenever you have cos here, you will get cos first, its counterpart next in the second term, right? You remember this formula like this. And whenever you have sin, you will get negative sign. Whenever you have cos here, you will get a positive sign. That is how you can remember these two formulas, right? And this is also a very important formula. Mostly in every problem, we have to use this formula for 2 or 3 times, right? Every problem. So this is most important formula that we are going to use in Fourier series. What is P of x? P of x is a polynomial. Sin ax or cos ax. You can have sin ax or cos ax, but the first one must be a polynomial. So whenever you have a polynomial multiplied by sine or cosine in the integration, you can directly write the formula like this. Polynomial into integration of sine ax. What is integration of sine ax? Minus cos ax by a, right? And you will get plus and minus alternatively. Here you have plus, here you have minus, next plus, next minus, right? So plus and minus opposite signs you will get alternatively. So you must get minus here, and then derivative of polynomial. Here you have p of x, here you have derivative. So first term you have to uh, take the derivative of polynomial, and you have to take the integration of the trigonometric term. That is the concept here. So polynomial and its derivative p dash and its derivative p double dash, next term p triple dash, like that. But second term, second factor is sin ax integration is minus cos ax by a. Integration of minus cos ax by a is minus sin ax by a square. Integration of minus sin ax by a square is cos ax by a cube, and so on, right? So this process, at the somewhere you will get this process will be terminated, right? Where it is going to terminated? Whenever the polynomial derivative becomes 0. So because it is a polynomial, when you keep on differentiating it, somewhere it will become a constant, and in the next term its derivative becomes 0, right? So here the process is terminated and you will get the answer. So here also you have polynomial and a cosine. The derivative, the first in the first term, you have to write the polynomial as it is. You should not take derivative, right? Uh, the integration of cos ax is sin ax by a. Integration of sin ax by a is minus cos ax by a square. Integration is of this is minus sin ax by a cube, and so on. Whereas derivative of p of x is p dash x, derivative of p dash x is p double dash x, p triple dash x, and so on. So you should remember it is positive and negative signs will come alternatively. So that is how you can remember these two formulas. And this formula is very, very important, right? We are going to use this extensively during all the problems, almost all the problems in this particular chapter, right? So we are going to solve some problems from the next video onwards. Please subscribe to my channel, like this video, leave a comment, you give your feedback, valuable feedback. Share this video with your friends. This is the introduction video. From next video onwards, we are going to solve problems on Fourier series. Okay, thank you.